A warm welcome to all of you, dear students. We were discussing regarding the postulates of Bose. So we have discussed all the first three postulates where exactly we discussed regarding the momentum of particularly orbit we have, and then we have discussed regarding the nucleus will be the central massive core with which it is surrounded by certain orbits, and all those things we have discussed in our last session. Now today we will continue with the same postulates with respect to fourth postulate of Bose. He has given certain postulates with respect to an atom. And one more thing I have defined, that an atom is a kind of tiny particle which cannot be seen by our naked eyes, and it is not going to be further divisible. This concept was given by Daltons, and right now we do not have any study regarding the Daltons. Further study was given by Bose, where he has subdivided the particles with particles present in it, like protons, neutrons, electrons, are considered to be subatomic particles. Fine. So now it means that an atom can be further having divided into particularly subatomic particles called as protons, neutrons, electrons. That is it. Now we will move to the next part, that is the radiation emitted or absorbed as a single quantum whose energy is equal to the difference in the energy of electron into orbits inward. So this, don't bother about this line at all. I will explain you with a very simple manner. The absorption or emission do takes place. I explained with the hydrogen spectrum in our last session that whenever a hydrogen tube is taken, hydrogen gas filled tube is taken, it is applied with a discharge, electric discharge. This is going to be passed over the prism. Then we will be observing lot many lines on a photographic film. That indicates some of the amount of wavelength is going to be absorbed, some of the amount of wavelength is also going to be emitted. Absorption is nothing but it is going to absorb, it is going to retain the energy with it. That electron is going to retain energy with it. Okay. Emission in the sense, whatever the energy it is going to absorb at its ground state, it will be moving to higher energy state, and it will be liberating back that energy to come back to the ground state. That is called as absorption and emission difference. I make the things still clear here by taking the example. Do see here the example. I'll be drawing the diagram for that one. I'll be having central nucleus. I'll be having certain orbits present here. Okay. I'll be having certain electrons present in an orbit also. Okay. So whenever we are going to provide amount of energy called as h nu, I'll be giving energy delta E equal to h nu, where h is said to be Planck's constant. So this h nu indicates that it is the minimum amount of energy. It is the minimum amount of photon. Quantum, it is also called as quantum of energy, which is going to be given to electron to move to the higher energy state. Once this electron is going to absorb amount of energy h nu, it will be moving to higher energy level. It gains certain amount of energy. It becomes unstable. Fine. Ground state, it was stable. Now as it is absorbing amount of energy, it will be moving to higher energy state. Okay. Once it moves to higher energy state, here it will be becoming unstable at higher energy level, so that it is going to lose a certain amount of energy, and it will be coming back to the original state. While coming back to original state, it may come to the state from where it has been excited, or it may come in between, or it may come exactly inner shells also, or inner orbits also. It is not necessary that from where exactly the electron been excited, it should come back to the same orbit. It is not necessary like that. That is the reason why in hydrogen spectrum we will be seeing various lines are going to be seen in hydrogen spectrum. Hydrogen spectrum, absorption spectrum, emission spectrum, all those things in detail we will do, but the thing is just understand this postulate given by Bose. What he is trying to tell here, emitted or absorbed energy, that is radiation, single quantum, it will be absorbed or emitted in the form of single quantum, photon, in the form of photon, because Bose, in this concept we are dealing with particle physical nature of wave. So what happens here? Whose energy is equal to difference in energy. That difference absorbed energy of electron is nothing but the difference between these two. That is from the ground state where it was electron, where it was presently, and when it is moving to higher energy state, that difference between these two is considered to be h nu. That difference energy itself is the energy absorbed by the electron. Okay, now it is going to that difference in energy of electron in two orbits. This was the first and this was the last. The difference is given as delta E equal to h nu. One photon of energy, delta E equal to h nu, is the minimum amount of energy given to the electron which will be able to excite to the first or higher energy level. That is a meaning of this whole sentence given by Bose. Now he has given that one in the form of this equation. This equation is said to be most important. You are supposed to remember this one. Next, he has given how exactly terminologies, like h is Planck's constant, then nu is frequency, and hence the spectrum of an electron will have certain fixed frequency. I will make these things still clear. The electron which is rotating in this first orbit, let me consider this as n equal to 1. It will be having a fixed frequency or angular momentum. The angular momentum of this electron which is rotating in first shell is exactly different from that of the electron which is rotating in a second, third, fourth and so on. Electrons will be having a fixed angular momentum or a fixed frequency. No two electrons of different orbits will have same values. They will be definitely having the different values for angular momentum. That is it given by Bohr's third postulate. Just copy this. We'll move to the next. So my dear students, we have seen exactly how line spectrum of hydrogen is being observed. In my last session with a diagram of a gas filled with hydrogen gas filled with a tube and it is going to be discharged, and we have seen many of the rays, electromagnetic radiations were passing over from the gas discharge tube and they are altogether passed over the prism. When they have been passed over the prism, when the light is or electromagnetic radiation is when it is coming out from the prism, it has shown a sharp lines occurring on a photographic picture. So now what exactly that meaning is? So whenever we observe that lines, why does those lines are particularly obtained in a discontinuous fashion? That we have to understand today. See here. So very first point regarding the line spectrum of hydrogen, I would like to tell you, or I would like to discuss here, that do understand this is the most important point. Once we understand these points what I have written, we are going to be we are going to succeed with a line spectrum of hydrogen. We can easily understand that one. Just see, first point, when electric discharge pass over the hydrogen gas at low pressure, it will form a line spectrum. So I once again in short I let you know the things. This is the glass tube in which we have filled with hydrogen gas. It is going to be connected to the electric discharge when high voltage is provided. Electric discharge in the sense we are going to provide the voltage. When voltage is being provided here, we will be observing electromagnetic radiations are going to be emitted from the glass tube. That is, those emitted radiations are going to be passed over the prism. Once we pass these radiations to the prism, what happens? We will be observing different types of electromagnetic radiations. I repeat my word, different types of electromagnetic radiations will be seen in the form of lines. They are observed in the form of lines, sharp lines, and those lines are discontinuous in fashion. They are not continuous. Those lines are discontinuous in fashion. That is, there is a certain difference is seen between these lines or the strips which are obtained on a photographic film. Why does that happens? We have to think of. Now see here. This is all the diagram representation I have given with respect to the first point. It is very common. We have discussed already and you will also be knowing this one. Let us move to the next point. What is that next point? Hydrogen molecule splits up into atoms. Electrons absorbs energy and get excited. This is the most important point I could say. See what happens. Whenever we consider hydrogen gas, we all know hydrogen generally exists in H2. Hydrogen gas having H2 molecule it is. It is not an atom. We are very much interested in particularly atom. So see what happens whenever hydrogen gas is discharged with the help of high voltage, it is going to liberate certain amount of electromagnetic radiation. Here hydrogen molecule what we have taken is going to split up into hydrogen atom. Hydrogen atoms will be having definitely electrons. Those are the electrons which are important. They absorb the amount of energy which is given in the form of electric discharge. They will absorb that energy. Once they absorb energy, I will let you know the things still clear. See here, I will be putting the diagram. I will be having electrons present here. When we provide hydrogen gas is going to convert into hydrogen atom. Hydrogen atom will be having electrons. They are going to be playing an important role during absorption of energy. I make things still clear in our mother tongue. See what happens. ಇಲ್ಲಿ ಏನು ತಗೊಂಡಿರ್ತೀವಿ ನಾವು ಗ್ಲಾಸ್ ಟ್ಯೂಬ್ ಒಳಗೆ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಅನ್ನು ಫಿಲ್ ಮಾಡಿರ್ತೀವಿ. ಈ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸಿಗೆ ಹೈ ವೋಲ್ಟೇಜ್ ಏನು ಮಾಡ್ತೀವಿ ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀವಿ. ಹೈ ವೋಲ್ಟೇಜ್ ಪ್ರೊವೈಡ್ ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗ್ತೈತಿ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಸ್ಪ್ಲಿಟ್ಸ್ ಅಪ್ ಇಂಟು ಆಟಮ್ಸ್. ಆಟಮ್ಸ್ ಏನು ಮಾಡ್ತಾವು ಆಟಮ್ಸ್ ದೇ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನು ಮಾಡ್ತಾವು ಯಾವ ಎನರ್ಜಿ ಏನು ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀವಲ್ಲ ಅದನ್ನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊತಾವು. ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡು ದೇ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಮೂವಿಂಗ್. ದಟ್ ಈಸ್ here electron first ಏನಿತ್ತಿಲೆ first orbit ಒಳಗಿತ್ತು electron. As soon as we give energy to this one, it will be moving to next energy levels or energy shells. ಯಾಕೆ ಮೂವ್ ಆಗ್ತಾವು ಅವು ಕಡೆ ಏನು ಬಂದಿರ್ತೈತಿ they have been absorbed energy. ಆ ಎನರ್ಜಿ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡಿರೋದನ್ನ ಏನು ಮಾಡ್ತಾವು they will jump ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತಾವು. ಎನರ್ಜಿ ಸಿಕ್ಕರೆ ಏನಾಗ್ತೈತಿ ಡೆಫಿನೆಟ್ಲಿ they will jump. Okay, they will jump in such a manner that they will be moving to next energy levels or next energy shells. Once they move to next energy shells, they are going to not stable at that energy state. ಇನ್ನೊಂದು ವಿಷಯ ತಿಳ್ಕೊರಿ ಇಲ್ಲಿ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವಾಗ ಮೂವ್ ಆಗ್ತೈತಿ it will be definitely absorbing certain amount of wavelength, certain amount of energy. Okay, ಈಗ hydrogen gas we have filled, it will be having many atoms. ಬೇರೆ ಆಟಮ್ಸ್ ಒಳಗೆ ಬಹಳಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಇರ್ತಾವೆ. ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ ಫಿಕ್ಸ್ಡ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿನ ಏನು ಮಾಡಲ್ಲ ಅಬ್ಸಾರ್ಬ್ ಮಾಡಂಗಿಲ್ಲ. ಬೇರೆ ವೇವ್ ಲೆಂತ್ ಅಥವಾ ಬೇರೆ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿನ ಏನು ಮಾಡ್ತಾವೆ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೋತಾವೆ. ಓಕೆ, ಒನ್ಸ್ ದೇ ಅಬ್ಸಾರ್ಬ್ ದೇ ವಿಲ್ ಬಿ ಎಕ್ಸೈಟೆಡ್. ಇನ್ ದ ಸೆನ್ಸ್ ಎಷ್ಟು ಎನರ್ಜಿ ನಾವು ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡಿರ್ತಾವೋ ಅಷ್ಟು ಎನರ್ಜಿ ತಗೊಂಡವು ಏನಾಗ್ತಾವೆ ನೆಕ್ಸ್ಟ್ ಶೆಲ್ಲಿಗೆ ಹೋಗ್ತಾವೆ. ಐ ಮೀನ್ ನೆಕ್ಸ್ಟ್ ಎನರ್ಜಿ ಲೆವೆಲಿಗೆ ಹೋಗ್ತಾವೆ. Once they move to next energy level, all the electrons of all the hydrogen atoms will never move to the same energy level. They will be moving to different energy level. Once they move to different energy level, definitely they are unstable. They will be coming back. They will be coming back to the ground state. ಯಾವಾಗ ವಾಪಸ್ ಬರ್ತಿರ್ತಾವಲ್ಲ ಗ್ರೌಂಡ್ ಸ್ಟೇಟಿಗೆ ಅವು ಏನು ಮಾಡ್ತಾವು ಎಲ್ಲ ಈಗ ನೋಡ್ರಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಮ್ಮ ಕಡೆ ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಥರ್ಡ್ ಫೋರ್ತ್ ಫಿಫ್ತ್ ಇಲ್ಲಿ ಮಟ್ಟ ಇದನ್ನ ತಿಳ್ಕೊರಿ. ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಏನು ಮಾಡ್ತು ಎನರ್ಜಿ ತಗೊಂತು ಲಾಸ್ಟ್ ಶೆಲ್ಲಿಗೆ ಹೋಯ್ತು. ಓಕೆ, ಇಮ್ಯಾಜಿನ್ ಇಟ್ ಈಸ್ ಲಾಸ್ಟ್ ಶೆಲ್. ಸೆಕೆಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಏನು ಮಾಡ್ತು ಇಟ್ ವಿಲ್ ಬಿ ಮೂವಿಂಗ್ ಟು ಇನ್ನರ್ ಶೆಲ್. ದೆನ್ ಥರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇಟ್ ವಿಲ್ ಬಿ ಮೂವಿಂಗ್ ಟು ಇನ್ನರ್ ಶೆಲ್. ಇದೇನಿದೆ ಎಕ್ಸೈಟ್ ಆದಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇವು. This excited electron which is present in a last shell may come back to first, or it may come back to second, or it may come back to third. It is not fixed that it has to come back to first only. That is what I am trying to convince you. Similarly, this electron which is absorbed, excited from here, it will be coming back to here, or it may come back to inner shell also, due to which we will be seeing different wavelength or discontinuous lines in the photographic film. ಇಲ್ಲಿದೆಲ್ಲ ಫೋಟೋಗ್ರಾಫಿಕ್ ಫಿಲ್ಮ್. ಈ ಫೋಟೋಗ್ರಾಫಿಕ್ ಫಿಲ್ಮ್ ಒಳಗ ಡಿಫ್ರೆಂಟ್ ಸ್ಟ್ರಿಪ್ಸ್ ವಿ ಆರ್ ಸೀಯಿಂಗ್ ಆರ್ ಡಿಫ್ರೆಂಟ್ ಲೈನ್ಸ್ which are discontinuous in fashion are seen is mainly because of electrons absorbed energy and electrons emitted energy is entirely different in case of all the atoms present in hydrogen molecule. So only the reason we will be observing different lines here. Okay, now let us move to the third point. When excited electrons comes back to ground state, they will emit electromagnetic radiations of discrete frequencies. As I told you, whatever the energy being absorbed by the electron is going to be moved to the higher energy level, and it will be coming back to with a different frequencies or different wavelength. Now last point you can see here that when these electromagnetic radiations pass through the prism, they will be coming back, they will be coming back in the sense they will be releasing energy, whatever energy they have gained, and they will move to higher energy, and when they coming back to ground state they will release that energy. When they get coming back, they release energy, that is called as emission. When they gain energy, they move to higher energy level, that is called as absorption. That is the main difference. In absorption, generally all the not we do not have discontinuous spectrum. Continuous spectrum we will be seeing absorption. In emission what happens? Discontinuous, because they will be having different energy levels. That is it what exactly this point tells us. That is, electron, when these electromagnetic radiations pass through the prism, lines are formed. How? Which are discontinuous in fashion. That is why always remember, hydrogen spectrum definitely shows us discontinuous line spectrum. Based on this discontinuous line spectrum shown by the hydrogen, we will be having different kind of series. Once it comes from last shell to first shell, that is n equal to 1. If it is coming back to n equal to 2, if it is coming back to n equal to 3, based on that, those electrons coming back to the energy levels, we will be having certain series with respect to these electrons movement, absorption, emission. So once we are particularly in detail study regarding the emission spectrum. So what happens in emission spectrum? What are those series which have been explained by various scientists and which have been most widely accepted? We will have that most interesting chapter or the most interesting topic of this line spectrum. We will start with that one. Just copy this. We'll move to next. So dear students, we understand how exactly series of hydrogen atom are going to be seen here, and let us understand them in detail. Just listen to me very carefully. It is the most important, somehow little tricky, but once we understand, the things are very awesome for us further. So see here, I have mentioned here, this is a series column, this is N1 column, this is N2 column, and this is said to be spectral region. Just listen to me. When I told you electron will be moving to higher energy state, before it was there in a ground state. When we consider electron present in the ground state, then we will be considering it as n equal to 1. If it is present in n equal to 1 range or n equal to 1 energy level, we can also tell that electron may present in n equal to 2 also. See, just I'll let you know. If the thing is, just leave this one, don't worry about this one, later I'll explain. Let us come here first. We have seen there is a formation of a kind of discontinuous spectrum of hydrogen. So we supposed to understand, or we have to interpret what exactly that hydrogen spectrum obtain. Listen to me carefully. When an electron is present, let me consider electron is present here, that is in N1. It may jumps to any of the other orbits. It is not necessary that we will be having only fixed orbits. There are infinity of orbits are present. Infinity in the sense, if you consider I am here, I am an electron in the ground state, I may jump to the sky also. So many number of electrons are present. And when I can be able to, electron from my side can be able to jump to the sky, it means that may come back to sky also. that may come back to any energy states. That means whenever there are various, that is various numerous energy levels are present in the sense, we can consider them as infinity. Do remember what I am telling here. So we will be having infinity number of orbits. Electron may jump to any infinity. The orbits which just now I have mentioned here, up to n5, n6, n7, n8, 9, so on up to infinity orbits we have. See here, when electron is jumping to the n2, that is the second energy level or second orbit. Second orbit, it may come back to the ground state. If it is the ground state for an electron, when electron is being given energy, it will be jumping to higher energy level. It may go to n equal to 2, it may go to n equal to 3, it may go to n equal to 4, or it may also go to n equal to 5. So whoever all electrons are jumped to the different energy states, they must have to come back. Once while coming back, electrons, if they are coming to n equal to 1, I repeat my words, when jumped electrons which are present in different energy states are coming back to the n equal to 1 value, then that series is called as Lyman series. That series is called as first series, Lyman series. Likewise, if electron is jumped to n equal to 5, n equal to 4, see here, it is being jumped first to n equal to 3, n equal to 4, then I have n equal to 5. If at all the different energy state electron which is jumped due to absorption of certain radiation, it will be coming back to n equal to 2. If at all electron is jumping from n equal to 2, from different orbits to n equal to 2, they are jumping. That is here, from n equal to 5 it is there, n equal to 4 is there, n is 3 is there. That is, these are different energy states where electrons are jumped. They will be coming back to n equal to 3. All the electrons which are coming back to n equal to 3, then it is called as Balmer series. Okay. Now next we have Paschen series. If all the excited electrons coming back to n equal to 3, then that series is called as Paschen series. This is the thing. I give you one day-to-day life so that the things will become more clear to you. So somebody wants to have a jumping competition. Some students or some people, group of crowd, they want to have a jumping competition. See here. Let me use my mother tongue itself. One person out of 8 to 9 persons, which you can imagine them as a electrons, ಏನು ಮಾಡಿದ್ರು ಅವರು ಎಲ್ಲರೂ ಏನು ಮಾಡಿದ್ರು, ಒಂದು 10 ಫ್ಲೋರಿನ ಬಿಲ್ಡಿಂಗ್, 10 ಫ್ಲೋರ್ ಬಿಲ್ಡಿಂಗ್ ಐತಿ. ಆ ಬಿಲ್ಡಿಂಗ್ ಒಳಗೆ ಏನು ಮಾಡಿದ್ರು, ತಮ್ಮ ಕೆಪಾಸಿಟಿ ಪ್ರಕಾರ ಏನು ಮಾಡಿದ್ರು ಅರೇಂಜ್ ಆದ್ರು. ಒಬ್ಬೊಬ್ಬ ಏನು ಮಾಡಿದ, ಸಾಕಪ್ಪ ನಂಗೆ ಫಸ್ಟ್ ಫ್ಲೋರ್ ಅಷ್ಟೇ ಸಾಕು, ನಾನು ಬಿದ್ದು ನಾನು ಸತ್ತ ಬಿಡ್ತೀನಿ, ನಂಗೆ ಆಗಂಗಿಲ್ಲಪ್ಪ ಅಂತ ಹೆದರ್ಕೊಂಡು ಫಸ್ಟ್ ಫ್ಲೋರಿಗೆ ಹೋದ. ನಾ ಶಕ್ತಿಮಾನ್ ಅದೀನಿ, ನನಗೇನು ನಡೀತದಪ್ಪ ಅಂತ ಹೇಳಿ ಸೆಕೆಂಡ್ ಫ್ಲೋರಿಗೆ ಒಬ್ಬ ಹೋದ. ನೆಕ್ಸ್ಟ್ ಥರ್ಡ್ ಫ್ಲೋರಿಗೆ ಒಬ್ಬ ಹೋದ, ಫೋರ್ತ್ ಫ್ಲೋರಿಗೆ, ಫಿಫ್ತ್ ಫ್ಲೋರಿಗೆ, ಇನ್ನೊಬ್ಬ ಏನೋದ ಸಿಕ್ಸ್ತ್ ಫ್ಲೋರಿಗೆ ಹೋದ. ಓಕೆ, ಹೋಗಿ ಏನು ಮಾಡಿದ್ರು ಅವರು, ದೇ ವಾಂಟ್ ಟು ಶೋ ದೇರ್ ಕೆಪಾಸಿಟಿ, ಹೌ ಮಚ್ ದೇ ಕೆಪಾಸಿಟಿ ಹ್ಯಾವ್ ಆಫ್ ಜಂಪಿಂಗ್. ಜಂಪ್ ಮಾಡಿದ್ರು ಕೂಡ ಅವ್ರಿಗೆ ಏನೂ ಆಗೋಲ್ಲ ಅನ್ನೋ ಲೆಕ್ಕಕ್ಕೆ ಅವ್ರು ಹೋದ್ರು. ಓಕೆ, ಒಬ್ಬ ಏನು ಮಾಡಿದ, ಫಸ್ಟ್ ಫ್ಲೋರಿಗೆ ಜಂಪ್ ಮಾಡಿದ. ನನಗೆ ಭಾಳ ಶಕ್ತಿ ಐತಿ, ನಾನು ಅಲ್ಲಿಂದ ಬೇರೆ ಫ್ಲೋರ್ನಾಗಿಂದನೂ ಏನು ಮಾಡ್ಬೋದು, ಫಸ್ಟ್ ಫ್ಲೋರಿಗೆ ಜಂಪ್ ಮಾಡಿದ್ರೆ ನಂಗೆ ಏನೂ ಆಗೋಲ್ಲ ಅಂತೇಳಿ 8ನೇ ಫ್ಲೋರ್ಲಿಂದ ಫಸ್ಟ್ ಫ್ಲೋರಿಗೆ ಜಂಪ್ ಮಾಡಿದ. ಶಕ್ತಿಮಾನ್, ಏನೂ ಆಗಲಿಲ್ಲ, ಹಂಗೆ ಆರಾಮ್ ಬಿಂದಾಸ್ ನಕ್ಕೊಂತ ಮನೆಗೆ ಹೋದ. ಆಮೇಲೆ ಏನಾಗಿದೆ, 7th ಫ್ಲೋರ್ ಎಲ್ಲಿ ಜಿಗದ, ಫಸ್ಟ್ ಫ್ಲೋರಿಗೆ ಜಿಗದ. ಲೈಕ್ ವೈಸ್ ಎರಡನೇದವ ಏನು ಮಾಡಿದ, 7th ಫ್ಲೋರ್ನೊಳಗಿದ್ನಲ್ಲ ಅವನು ಜಿಗದಪ್ಪ, ಫಸ್ಟ್ ಫ್ಲೋರಿಗೆ ಜಿಗದ, ಏನೂ ಆಗಲಿಲ್ಲ, ಆರಾಮ್ ಖುಷಿ ಆಯಿತು, ಹೋದ. ನೆಕ್ಸ್ಟ್ 5th ಫ್ಲೋರ್, 4th ಫ್ಲೋರ್, 6th ಫ್ಲೋರ್ನಾಗ ಎಲ್ಲರೂ ಇದ್ದವರು, ಅವ್ರು ನೋಡಿ ಖುಷಿ ಆಯ್ತಪ್ಪ, ಇವರೆಲ್ಲರೂ 1ನೇ ಫ್ಲೋರಿಗೆ ಜಂಪ್ ಮಾಡೋದಾರ, ಅಲ್ಲಿಂದ ಜಂಪ್ ಮಾಡತ್ತಾರ, ನಾವು ಇಲ್ಲೇ ಜಂಪ್ ಮಾಡೋಣ. 3rd ಫ್ಲೋರ್, 2nd ಫ್ಲೋರ್, ಆಮೇಲೆ 4th ಫ್ಲೋರ್ನಾಗ ಇದ್ದವರು ಏನು ಮಾಡ್ತಾರೆ, ವಾಪಸ್ ಬಂದು ಸೀದಾ ಗ್ರೌಂಡ್ ಫ್ಲೋರಿಗೆ ಜಂಪ್ ಮಾಡ್ತಾರೆ. ಯಾರ್ಯಾರು ಬೇರೆ 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 ಫ್ಲೋರ್ನಾಗಿದ್ದವರು ಎಲ್ಲರೂ ಗ್ರೌಂಡ್ ಫ್ಲೋರಿಗೆ ಜಂಪ್ ಮಾಡಿದ್ರಲ್ಲ, ಆ ಜಂಪ್ ಮಾಡಿದಂಥ ಫ್ಲೋರ್ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಲೈಮನ್ ಸೀರೀಸ್. ಗೊತ್ತಾಯಿತು. ಇವಾಗ ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡೋಣ. ಏನಾಯಿತು, ಇದು ಎಲ್ಲರೂ ಗ್ರೌಂಡ್ ಫ್ಲೋರಿಗೆ ಸಿಗಿದ್ರೆ ಇಟ್ ಈಸ್ ಕಾಮನ್, ನೆಕ್ಸ್ಟ್ ಏನು ಚೇಂಜ್ ಮಾಡೋಣ ಅಂದ್ಕೊಂಡ್ರವರು ಟಾಪಿಕ್ ಚೇಂಜ್ ಮಾಡೋಣ, ಕಾನ್ಸೆಪ್ಟ್ ಚೇಂಜ್ ಮಾಡೋಣ. ಎಲ್ಲರೂ ಯಾವುದಾದ್ರೂ ನೀವು ಇನ್ಫಿನಿಟಿ ಮಟ್ಟ ಹೋಗ್ರಿ, ನೀವು ಲಾಸ್ಟ್ ಫ್ಲೋರಿಗಾರ ಹೋಗ್ರಿ, ಒಲ್ಲಪ್ಪ ನಾನು ಆಕಾಶಕ್ಕೆ ಜಂಪ್ ಮಾಡ್ತೀನಿ, ಏರೋಪ್ಲೇನ್ ಆಗಿಂದ ಜಂಪ್ ಮಾಡ್ತೀನಿ, ನಾನು ಏರೋಪ್ಲೇನಾಗ ಹೋಗ್ತೀನಿ ಮ್ಯಾಲೆ ಅಲ್ಲಿಂದ ಜಂಪ್ ಮಾಡ್ತೀನಿ ಅಂತ ಒಬ್ಬ ವಿಚಾರ ಪಡಿಲ್ಲ. ಇನ್ನೊಬ್ಬ ಹಾಟ್ ಏರ್ ಬಲೂನ್ ಹತ್ತು ಕೂತ್ಕೊಂಡು ಅಲ್ಲಿಂದ ನಾನು ಜಂಪ್ ಮಾಡ್ತೀನಿ. ಎಲ್ಲಿ ಮಟ್ಟ ಹೋದ್ರವರು ಹಾಟ್ ಏರ್ ಬಲೂನು, ಏರೋಪ್ಲೇನ್, ಆಕಾಶಕ್ಕೆ ಹೋದ್ರು, ಆಮೇಲೆ ಲಾಸ್ಟ್ ಫ್ಲೋರಿಗೆ ಹೋದ್ರು, ಲಾಸ್ಟ್ ಬಟ್ ಸೆಕೆಂಡ್ ಫ್ಲೋರ್, 8th ಫ್ಲೋರ್, 7th ಫ್ಲೋರ್, 5th ಫ್ಲೋರ್, ಹಿಂಗೆಲ್ಲ ಹೋದ್ರು. ಹೋಗಿ ಏನು ಮಾಡಕತ್ರ ಅವರು ಎಲ್ಲರೂ ಫಸ್ಟ್ ಫ್ಲೋರ್ ಬಿಟ್ಬಿಟ್ರಿ. ಇನ್ನು ಫಸ್ಟ್ ಫ್ಲೋರ್ ಬಿಟ್ಟು ಸೆಕೆಂಡ್ ಫ್ಲೋರಿಗೆ ಜಂಪ್ ಮಾಡಕತ್ರು. ಹಾಟ್ ಏರ್ ಬಲೂನ್ ಸೆಕೆಂಡ್ ಫ್ಲೋರ್, ಏರೋಪ್ಲೇನ್ ಸೆಕೆಂಡ್ ಫ್ಲೋರ್, ಲಾಸ್ಟ್ ಫ್ಲೋರ್ ಟು ಸೆಕೆಂಡ್ ಫ್ಲೋರ್, ಥರ್ಡ್ ಫ್ಲೋರ್ ಟು ದ ಸೆಕೆಂಡ್ ಫ್ಲೋರ್, 7th ಫ್ಲೋರ್ ಟು ದ ಸೆಕೆಂಡ್ ಫ್ಲೋರ್. ಬೇರೆ ಕಡೆಯಿಂದ ಎಲ್ಲರೂ ಬಂದು ಎಲ್ಲಿ ಜಂಪ್ ಮಾಡಕತ್ತಾರ, ಸೆಕೆಂಡ್ ಫ್ಲೋರಿಗೆ ಜಂಪ್ ಮಾಡತ್ತಾರ. ದಟ್ ಸೀರೀಸ್ ಡಿಫ್ರೆಂಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಕ್ಸೈಟೆಡ್ with a different energy, they will be coming back and they are retaining or they are jumping to n equal to 2 series. That series is called as Balmer series. For your surprise, this Balmer series is called as visible. It will be seen in visible region. This is Balmer series, comes under visible region. That is what all those things I have written here. Similarly, see here, Pascal series. Again competition starts. Now all of them left second floor. They start jumping to the third floor, last floor to third floor, fourth floor to the third floor, 8th floor to the third floor. They start jumping from infinity to third floor. They are coming. Then that series is called as Pascal series. Fine. So the same things I have explained here, I have written. I will make you the things still easy. Just look at me. Just be concentrate here. Lyman series, first ground state, they will be coming. From where they are coming? From 2, 3, 4, 5, 6, 7 and infinity. And in Balmer series, they are coming from where they are coming? Definitely they are coming to second floor itself, not first floor. First floor igmandad yen agtadi, it is called as Lyman series. They are coming to second floor. Okay, second floor ಗೆ ಎಲ್ಲಿಂದ ಬರತಾರ? Third floor, 4th floor, 5th, 6th, 7th, 8th and infinity. That is called as Balmer series. Likewise, we have Pascal series. Pascal series is said to be n equal to 3 value. That is third floor. Day life example ನೀವು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ n equal to 3. ಬೇರೆ ಫ್ಲೋರ್ ಲಿಂದ n equal to 3 ಸ್ಟೇಟಿಂಗ್ ಏನು ಮಾಡತಾವು, ಜಂಪ್ ಆಗತಾವು ಎಲೆಕ್ಟ್ರಾನ್. That is called as infrared region or infrared series. Pascal series that will be seen in infrared range. A wavelength range ಏನೈತಲ್ಲ, ಆ ರೇಂಜಿಗೂ ಕೂಡ ಏನು ಕೊಟ್ಟರು, ಹೆಸರು ಕೊಟ್ಟರು. ಫಸ್ಟ್ ಒನ್ Lyman series ಎಲ್ಲಿ ಲೈ ಆಕೈತಿ? ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಲೈ ಅಂಡರ್ ultraviolet series or ultraviolet region. Second Balmer series we have. Balmer series, where it lies? It lies in visible region. So the thing is, we will see various colors, skin color, clothes, board, light, everything color we can be easily see them. But for the others, we generally go for the other spectroscopic method. So don't worry about that one. Now we have Pascal series. Pascal series present under infrared. As well, we have bracket series, Piffon series also in infrared, slight just variation in the infrared wavelength. With those slight variations, these three, that is Pascal, bracket, Piffon series are going to be lie in those wavelength range. Lastly, we have Hamfari, that is far infrared region. We will be seeing. This is all about interpretation of hydrogen spectrum. Why does this changes of electron shown as lines in a photographic film? Based on these series, we can calculate the wave number. With the help of that wave number calculation, we have a small cute equation. We will have that equation and we'll move to next. Just copy this, we'll start with that. So dear students, whatever so far we have discussed till now regarding the spectral lines, those spectral lines will be obeying certain formula with which we can calculate the wave number. I repeat my words, spectral lines, whatever we have seen so far with a different series, they are going to obey this formula which is used for the calculation of the wave number. Nu bar is wave number. So Balmer, Lyman and Paschen, so on, all the scientists who all worked upon the hydrogen spectrum, they were fighting. So I could take my name, I could write my name and so on, they were fighting. That time one scientist who made use of all these controversies, and he has given one particular value. See here, that is nu bar, which is called as wave number, is also referred as 1 by lambda, inverse lambda, which is going to be given by scientist Rydberg. So formula given by particularly Rydberg. With his constant, this formula is going to be applicable for all the series of spectral lines of hydrogen atom. So see here, nu bar equal to 1 by lambda. Here RH, what I have written, it is called as Rydberg constant. We call it as Rydberg constant. He has defined this formula, and this formula holds good for all the series. So he has named himself to this formula with a Rydberg's equation. And here 1 by n1 square minus 1 by n2 square I have written. n1 square is nothing but electron from which state, energy level it has moved, from where it has moved. n2 is nothing but to which side or which energy level it is coming back, from where it went to where it is coming. That is it. That difference is going to be used for the calculation of wave number. That is it. And see here, n1 I have written from where electron left, n2 is from where electron is coming. It has been moved to the different sides, but where it is coming, whether it is coming to n1 or it is coming to n2 or it is coming to n3 and so on, that calculation can be done with the help of wave number equation. And the Rydberg, as he has given this equation, he has named it as Rydberg's equation. And the Rydberg constant value also, he has made so many practicals and all these things, those things, everything complex mathematics he has done. At last he has given this value, that is RH, Rydberg constant is 109,677 per centimeter. This is called as Rydberg's constant. This is called as Rydberg's constant. With the help of this value, we can calculate wave number for any series like Lyman, Balmer, Paschen and so on. And we can calculate wave number also, that is spectral lines, how they are going to be calculated of hydrogen atom. Those will be given by this formula. This is the most important formula. Based on this, definitely you are going to get questions in your board examination. Be thorough with the formula. Just remember this one. We are supposed to put the values for n1 and n2. That's it. And RH value at least will be given. Rydberg's constant value we have to remember. Or sometimes in the examination, questions will be given with this one. We are supposed to substitute and we are supposed to calculate and simplify the equation and get the answer. That is it. And we will do that one by one. Just copy this. We'll move that. So dear students, let us discuss regarding Lyman series. So Lyman series is the first series we have discussed. We have seen how spectral lines of the hydrogen atom have been shown with a different series. That interpretation of hydrogen atom we have seen. Now see here, we discuss something regarding how we can write the formula for Lyman series. It is very simple, just do concentrate here. Lyman series is said to be the first spectral series of hydrogen atom which was lying in UV region, ultraviolet region. Okay, and this was given by scientist Lyman in the year 1898. As I told you, N1 is said to be one value. If you consider Lyman series particularly, we will be writing N1 is 1 because it is the first. N1 value will be given here because it is the first series. Now N2 will be given as 2 because N1 will be its ground state from electron goes, and N2 is nothing but excited state. N2 may be second excited state, third excited state, fourth and so on. So with this brief idea, we can write the formula here. Nu bar equal to, that is nothing but 1 by lambda, or it is also given by Rydberg's constant. We will be having 1 by n1 square I am writing here because n1 is 1 I have taken. minus, I have taken n2 value also, which is n2 square. This was the equation. Now I could write here that n1 is 1 here, n2 value will be 2, 3, 4 and so on up to infinity it goes. So this is the equation or the formula is holds good or represented for Lyman series, where I could write here 1 by n1 square is ground state where electron is present, and n2 is nothing but excited state. Those excited states may be 2, 3, 4 and up to infinity. They will move to so many states, up to infinity they go, but they have to come back to ground state, which is n1 value is 1. This was given by Lyman and in the year 1898, which is considered to be a first series for this spectral series. Copy this, we'll move to next. Let me make the things still more clear to you. See here, as I told you, n1 is 1. That is, it is Lyman series will be lying at first state, that is called as ground state or first energy shell or energy level. So I could write for with respect to this one, I can write here nu bar equal to 1 by lambda we can write, or directly we can also write R, that is Rydberg constant. The thing is, I have to mention here n1 square is nothing but 1 square I have to write, because it is n1 is fixed for Lyman series, it is 1 first ground state. Here I could consider, if at all the n2 value will be given to you, n2 value may be 2, 3, 4, 5 and so on up to infinity, because where exactly electron from where it is coming, that is going to be considered as n2. Okay, so 1 by 1 square divided 1 by 1 square minus, I will be considering n2 value. N2 value must be given to us. Based on n2 value given to us, we can calculate the wave number. So n2 value, if n2 value is given as 2, then I must have to consider it as 2 square, or directly I can also write it as n2 square. Don't get confused with this one. 2 are same here, madam. How to do this one? n2 is nothing but any state, that is 2, 3, 4 up to infinity we can consider. n1 is ground state of electron. Ground state in the sense where it has to come, wherever it may be. n2 may be 2, 3, 4, 5, anything. All those are said to be n2 values. Second ಆದ್ರೂ ಇರಬಹುದು, ಥರ್ಡ್ ಸ್ಟೇಟ್ ಆದ್ರೂ ಇರಬಹುದು, ಫೋರ್ತ್ ಸ್ಟೇಟ್ ಒಳಗಾದ್ರೂ ಎಲೆಕ್ಟ್ರಾನ್ ಇರಬಹುದು. ಅದು ಕಂಪಲ್ಸರಿ ಎಲ್ಲಿ ಜಂಪ್ ಮಾಡಬೇಕು? n1 ಗೆ ಜಂಪ್ ಮಾಡಬೇಕು. For Lyman series, what is n1 value? It is 1, because it is first series. n2, it may come from second to first, third to first. That is the reason why n2 may be 2, n2 may be 3, okay, or n2 may be 4, n2 may be 5 up to infinity it may be. Infinity ಲಿಂದ ಕೂಡ ಅದು ಎಲ್ಲಿ ಜಂಪ್ ಮಾಡಬಹುದು? n1 value ಗೆ. n1 is 1, ಇಲ್ಲೇ ಜಂಪ್ ಮಾಡಬಹುದು. That is what I wanted to tell you. But this is the final equation what we can write for 1 by 1 square minus 1 by n2 square. In your examination, what they do, they will be giving you n2 value. Based on that n2 value given, you can do calculate the wave number given here. That is it. So this is all about Lyman series. Copy it. We'll move to next. Coming back to Balmer series, dear students, we have to understand here it is very fast found. I mean to say here, before Lyman series, we will be having first series as a Lyman series. Before we found the Lyman series, we found Balmer series. Balmer series will be lying under visible region. Let us have a glance regarding this one. We will be having energy levels n equal to 1, 2, 3, 4, 5, 6, 7. Now we understand how does electrons jumps to Lyman's particularly Balmer series. How they go, how we do understand that one, see here. From 7th energy state, they may come to second, and from 6th they may come to second, because the second energy state itself is considered as Balmer series. So whatever the electrons are there in a 7th, 6th, 5th, 4th, they must have to come to n equal to 2 itself. This is referred as Balmer series. This is kind of fixed or limiting series where all the electrons has to jump to n equal to 2 itself. Now what would be the formula? N1, at least we came to know it is a second state. Energy state is nothing but it is a second in case of Balmer series. So N2 value, if you consider, electrons may jump from third to second, fourth to second, fifth to second, sixth to second, and so on. So the formula which was given by the Rydberg is referred as nu bar equal to 1 by lambda. RH is Rydberg's constant, and N1 square, N2 square are I already explained you. With respect to Balmer series, what we have to mention here, see, nu bar equal to 1 by lambda we will be having, this is RH. We know that N1 is, it is fixed, that is 2, energy state 2. How I must have to mention? I must mention here that 2 square, it will become N1 value we have taken here, that is this I must write it as N1 square value is 2. Okay, so these are energy shells. I will be considering 2 square. N2 we don't know, it is not given. N2 square we will be applying here. So finally what we could write here, we can write that 1 by lambda equal to 1 by 4 minus 1 by N2 square. Like this we could write. So this is the calculation of wave number with respect to Balmer series. What will be the final formula we get here? Finally we get nu bar equal to 1 by lambda, that equal to 1 by 4. You can write this 1 by lambda or you can skip also, no problem. Based on the question asked, we can make change of these lambda values. Wave number directly they are asking, we can put this 1 by lambda and RH value. If at all directly they are asking for lambda inverse, that is reverse of this one, we will be considering. Okay, so when you consider nu bar 1 by lambda equal to N1, we came to know it is 2 square is 4. I have taken minus 1 by N2 square. Here you will be given with the particular values of N2. You have to substitute and you have to go for the calculation. We will have certain numericals based on this one. We will do that one. Don't worry about that. Just copy this up to here. We'll move to the next. Now let us understand regarding limiting lines. What exactly the limiting lines means. So limiting lines, if you consider, we will be having various energy levels. Energy level 2, 3, 4, 5, 6 up to infinity we have. If at all Balmer series, if you consider, the electron has to jump to n equal to 2. Second energy state electron has to jump. From where all it can be able to jump, that kind of calculation is called as limiting line for Balmer series. Limiting line in the sense it may jump from 3 to 2, 4 to 2, 5 to 2 up to infinity. We will be having energy states or the energy levels. From infinity also we can have jump of the electrons to n equal to 2. So limiting line for the Balmer series, we can write here that, just check out here. Lambda bar, nu bar we have taken here. I will be taking 1 by lambda. Okay, that is further written by Rydberg's constant. We all know 1 by N1 square minus 1 by N2 square. This is the general formula given. And for particularly Balmer series, what we can consider? We can consider N1 square is 2, right? And for N2 square, we can consider, as I told you, from infinity also they can jump. That is the last line, or that is the last energy state, that is infinity, from above which we cannot have any values. That is infinity itself, it's the last. So that we will be considering. So N2 will be considered as infinity. If N2 is infinity, see here RH 1 by 2 square I can consider, minus 1 by infinity I can consider. Right? So once we consider like this, I will be having RH, that is 1 by lambda value equal to, I will be considering 1 by 4 minus 1 by infinity. Okay. So at last, if you write lambda value, now it will become, just multiply here, you will be having RH infinity, it will be having a 0 value almost. will be having RH 4. 2 square, that is 4 I can consider. After this equation I am writing. So 1 by lambda, what I have taken is becoming RH by 4. If you consider lambda value, then it will become 4 by RH is the limiting line for Balmer series. You need not to remember this Balmer series, particularly limiting lines. Those who are attending competitive exams like JEE and NEET, definitely questions will be asked with these formulas. You're supposed to have the idea regarding limiting lines. For particularly limiting line for Balmer series, we will be having lambda value 4 by RH. Okay, so this is the limiting line we can write for Balmer series. Likewise, previously if you consider, what was the previous one before Balmer series, which comes? Lyman series comes. Lyman series particularly for the hydrogen atom with only one electron with n equal to 1 value. N equal to 1 value in the sense what we can substitute here? We will be substituting 1 by 1 square. That means we will be getting 1 by RH value, where 1 n equal to 1. 1 square is 1 itself. That I would have told you, but the thing is there is no much of the changes occurs, but when you consider Balmer series, you do have to know these calculations and limiting line how we can draw here. So this is all about the Balmer series as well a limiting line for Balmer series. Based on this, definitely you are going to get the JEE questions and do practice this formula. You will be given with the values. Based on those values given, you are supposed to substitute them and you have to calculate. So just copy this, we'll move to next. Now coming back to the Paschen series, I could tell that the energy state we consider here it is n equal to 3. From various states of different energy states in which electrons are present has to move to n equal to 3 state itself. Now let us consider the wave number how we supposed to calculate here. We all know nu bar is nothing but 1 by lambda. Here we will be considering RH. And we will be having 1 by n1 square minus 1 by n2 square. This was the formula. Now you could do on yourself as you are viewing, and you supposed to tell me the limiting line or the values for this lambda by substituting n equal to 3, n1 equal to 3. So here I must write n1 square is 3, n2 square is infinity I can take here, or I can just remain it as n2 square also, but take it as n2 square is infinity value. Then we can consider nu bar equal to 1 by lambda equal to RH is going to be 1 by 3 square minus 1 by infinity. What you are going to obtain here? See, 1 by lambda you will be having RH. Okay, so here you will be having what? 9 square 3 square, you are going to get 1 by 9 square. Okay, now I mean 1 by 9 you are going to obtain, and this is 1 by infinity. At last, what will be the formula you are going to get? Nu bar equal to RH. Just do multiplication, you will be getting 9. So this is the value or the wave number we can write for particularly Paschen series. Nu bar will become RH by 9. The Rydberg constant divided by 9. We will be knowing the Rydberg constant value also. If at all you are going to consider lambda, then 9 becomes upper side and RH will be coming it down, and you will be getting the lambda value. Like this, just you do calculate and tell me for bracket series, wherein for bracket series you will be considering n value as 4. I will show here with just making the modification here itself, and you do pause your video and do tell me what will be the final equation we will be getting for nu bar for bracket series, wherein we will be considering n1 square equal to 4. I'll let you know here only. Just pause the video and do yourself and let me know that one what will be the value you are going to obtain for bracket series. Let me write the fourth series, which is called as bracket series. Let me write the values for them also. So now fourth one is said to be bracket series. When you consider bracket series, you will be having n1 value is 4. Let me show the this one also energy levels. We have 1, 2, 3. This is fourth energy shell we are interested, that is we are dealing with bracket series 5, 6, 7, 8 and so on. And from 5th to 7, 8, from 5th to n 4 it is coming 6, 4, then it is 7 to 4, then it is 8 to 4 it is coming. Now see here, nu bar value is nothing but 1 by lambda equal to RH. Okay, so now 1 by n1 square minus 1 by n2 square. I'm considering if n2 square, n1 square, if you substitute n1 square, at least we all know it is 4. n2 square we can write it is infinity also we can consider. Then nu bar equal to 1 by lambda equal to RH divided by 1 by 4 square we will be considering, and 1 by infinity. So in total nu bar value is going to be 1 by lambda equal to RH by 16. So this is the final value you are going to obtain for bracket series. Like that it goes. Once you consider 4, you are going to 16, RH by 16 you will be getting. Once you go for 5th energy level, you will be getting 5 square. Then RH by 25 you will be getting. Once you go for 6th energy shell, then you will be getting 6, 6, 36, RH by 36 value you will be getting, and so on it happens. So this is all about the series, calculation of wave number. We have seen how we can write the limiting lines also. So if you consider infinity, they all are said to be limiting lines for particularly those series, what calculation we are going to do. That is it. I hope till here you have understood thoroughly. Just copy this, we'll move to next.